Question 9b. 400 resistors are tested for 200 hours and 30 failures are found. Calculate the mean time between failures and the failure rate. Alright, now, the mean time between failures is the operating time divided by the number of failures. Now here, for the mean time between failures, what you have is the operating time. Now, the thing is, the more resistors you test, even though the time remains, the higher will be the mean time between failures. Right? If you have the same amount failing. So you must multiply the 400 resistors by 200 hours. Right? And then divide by the 30 failures found. If it was just one machine, it would be just the number of hours over the number of time it failed. But this is 400 of them. They must multiply. This is 4 2s 8, 0, 0, 0, 80,000 divided by 30, which is going to be what? We look at our calculator. So here, we have 80,000 divided by 30. 80,000 hours divided by 30. So 2,666. 2,667 hours. So you expect that each will last about 2,667 hours, right? The thing is, if there were 200 resistors, you would have 200 by 200 hours over 30, which is 40,000 over 30. What you would get from that, instead of 80,000 over 30, you would get 40,000 over 30. So 40,000 over 30 would be 1,333 hours. Which means they are half as reliable. They will last half as long. That's what it means. Half the time, half the number of hours will pass before each fails. Alright? Now, failure rate. That's going to be how many of them fail divided by the number of hours of operation, the time of operation. So, failure rate is number of failures, the number of failures over the time of operation. So now, 30 of them fail. Right? So you have 30 failures. Now remember, you have to account for the number of resistors there when you're going to calculate the time of operation. So it's going to be 400 resistors times 200 hours. So in this case, the failure rate is going to be 30 over 80,000, 80,000. So what is 30 divided by 80,000? Let's see. Let's try and get back our calculator. So here, 30 over 80,000 equal. Alright, so you have 3 zeros, 375. So it's 0.3 zeros, 375. What this is saying is the number of them that the failure rate here, right? The number of them that will fail per hour. Now, if we multiply this by 1, 2, 3, 4, 5, 6 by 1 million, multiply by 1 million, and multiply the denominator by a million also, what we get is 375 over 1 million. So 375 of them will fail after operating for a million hours. Now, we could cancel down even further. Suppose we divide 375 by 5, get 75. 375, suppose we divide it by 15. Alright, 25. 1, 1, 2, 3, 4, 5, 6 over 15. Alright. 1 million. I want to cancel down using fractions here. 1 million over 25 is 40,000, and 375 over 25 is 15. So 15 over 40,000. Let's put 15 over 40,000 and see what happens. 15 of them are expected to fail every 40,000 hours. So you expect 15 of them to fail every 40,000 hours. That's what it means. Suppose we divide 15 by 3. Oh, let's not do that. We want clean numbers. So let's divide 15 by 5. 15 over 5 is 3 over 40,000 over 5. 5 to 40, 8,000. 3 of them is expected to fail every 8,000 hours. So if you have 3 of them running, right, after 8,000 hours you expect 3 of them to fail. After that number of hours, you expect all 3 of them to last 8,000 hours. That's what it means, alright? So 3 failures every 8,000 hours. Let's see something else here. It says 300 resistors are tested for 40 hours. Calculate the expected failure rate. Alright, so 300 of them run for 40 hours. So 300 resistors, 40 hours. Good. Now, how many of them do we expect to fail after 40 hours? Let's look at the ratio. 3 failures over 8,000 hours is equal to, now here is X failures over 40 hours. Then we're going to multiply X by 300 since there are 300 of them. We're assuming it is only one for now. So if one of them fails, is run for 40 hours. You run the test for 40 hours. What do you expect to happen? X is equal to 3 times 40 over 8,000 equal. Alright, let's just use the calculator. 3 by 40 over 8,000 will give what? Three times 40 is that over 8,000 equal 0.015. So 0.015 of them will fail after 40 hours. But the number of failure, the number of them that will fail will be 300 times 0.015 equals. So here we have 300 by 0.0015. 300 times this equals 4.5. 4.5 of them out of the 300 is expected to fail after 40 hours, right? Remember, 3 of them fail after 8,000 hours. The 3 out of 8,000, by the way, it means 3 out of 8,000 equal this, and if you put 1 over this, there will be one failure every 2,667 hours. One fail every 2,667 hours, right? One of them will fail. Okay, so that's what you're saying. Now here, if it's only 40 hours, it's a fraction of this 2,667. It's going to be 0.015. But if it's 300 of them that you run for the 40 hours, then 300 by 0.015 give you 4.5 of them expected to fail out of that time. Alright, so that will be it for now. I'll see you in the next video.